So here's the last example in lesson 2.5 with regards to making a box plot or box and whiskers plot that is actually referred to as a modified box plot. I mentioned today at the end of class that in a modified box plot, what is done is that any data value that is considered an outlier is just noted in the box plot as a dot or a little star, separate from the separate from the whiskers of that box plot. So what we have to do first is to determine if the data set has any outliers. So to determine if the data set has any outliers, we're going to use a basic rule to determine what we call the boundaries beyond which outliers lie. So the way we determine if there are any outliers is we basically first calculate the value of the interquartile range, the spread of the middle 50% of the data, the Q3 minus Q1. We multiply that interquartile range by 1.5. And then we subtract that value from Q1 to get what we call the lower boundary. And we add that value to Q3 to get what we call the upper boundary. So basically anything that's more than 1.5 IQRs beyond the edges of the box in your box plot will be considered an outlier. So we had gotten for the males a Q1 of 15 and a Q3 of 46.5. And for the females, a Q1 of 21 and a Q3 of 31. So we want to find the interquartile range by subtracting Q3 minus Q1. So I'm going to take Q3 minus Q1 for the males, and that would be 46.5 minus 15, and that will give me the interquartile range. I'm going to multiply that by 1.5, and then I'm going to subtract that from Q1 to get the lower boundary. I'm going to do the same thing for the females. I'm going to find the interquartile range by taking Q3 minus Q1. 31 minus 21 is 10. And I'm going to multiply that interquartile range of 10 by 1.5. And then to find the lower boundary, I subtract that from the left side of the box. So the left side of the box is quartile 1, which has a value of 21 for the females. So 21 minus 1.5 IQRs, which would be 1.5 times 10 or 15. 21 minus 15 is 6. That's our lower boundary. Anything that is lower than that is considered an outlier. Well, clearly we see that there is a young lady in our data set who could only do one push-up. That's clearly less than 1.5 IQRs below Q1, and therefore that female's data value of 1 is an outlier. Now the upper boundary is found by taking the same value, 1.5 IQRs or 15, and adding it to the right side of the box, which is quartile 3. And in the females, that was 31. So 31 plus 15 is 46. Well, the highest number of push-ups that any female was able to complete was 38. So that's not above the upper boundary. Therefore, there are no upper outliers. So in this question, I only asked you to determine, well, first, if the female push-up data contains any outliers, and we've decided there is one. It is that female that only did one push-up. Now, let's do the same thing. Well, let's make a modified box plot for the females. So now the lowest value in the female data that is not an outlier is 9. 1 is an outlier, so that is going to be separated from the whisker on the lower side of the box. So when I go to make this modified box plot, I put a little dot or star at that outlier at 1. And then my whisker is only going to extend from 9 to quartile 1, which is 21. And the reason it's 9 to 21 is because 9 is the next lowest value. And then, of course, like we did in class, quartile 1 is at 21. Median is at 26, so we drew a line there. And then quartile is at 31. So the box is formed by connecting Q1 to Q3. So 21 to 31. And then we had no outliers on the upper end, and therefore the whisker on the upper side of the box is going to extend to that maximum value of 38 like it did in the non-modified box plot. So from the right side of the box, I just extended that whisker to the value of 38. That's a modified box plot. So now we can look at that and we can say, other than that outlier, the distribution of the number of push-ups these females could do is relatively symmetric, with a median value of 26, an interquartile range of 10, and one outlier at 1. Let me know if you have any questions. Just message me through Remind or send me a message through Canvas or via email.